Determine how many aliens can disinfect all of their hands. Here, even if there is not enough disinfectant left for an alien to disinfect all of their hands when they start, they will use up the remaining disinfectant. So this is a very easy question, straightforward. So what we have to do is, let's see the sample case. So for this sample case, what we have to do is, we have to check the sum. When it is more than 10, then we can stop counting. So 2, 1 alien can completely wash his hand. 2 plus 3 is 5. 2 alien can completely wash his hand. 5 plus 2 7. 3 alien. But now when the 5 is added to this, it becomes 12. So only 3. The count will be 3. We are taking N and L input. Then for every input, we are adding it to our sum and checking if it is less than or equal to M. If it is, then we are incrementing A. Else, we are coming out of our loop and then printing it. Is this clear? Like any doubt or problem in this question? Okay, so this was very simple one. Let's move on to the next question. Uppercase and lowercase. The problem statement is, you are given a string S consisting of lowercase and uppercase English letters. The letter of S is odd. If the number of uppercase letter in S is greater than the number of lowercase letter, convert all the lowercase letter in S to uppercase. Otherwise, convert all uppercase letters in S to lowercase. This is also another simple implementation based question. What we have to do, let's copy this. For this, how many uppercase letter? Uppercase count is 1, 2. And lowercase count is 1, 2, 3, 4, 5. What is given in question? That if uppercase is greater than the number of lowercase, then we have to convert all lowercase to uppercase. Otherwise, uppercase letter to lowercase letters. Okay. So here the lowercase is more. So we have to convert it all to lowercase. Okay. This is clear, right? So let's move to the implementation part. What we are doing, we are taking the inputs. Here is my solution. So we are taking the input. Then we are calculating the length of the string. Then for iterating it once, we are calculating the uppercase count and the lowercase count. If the uppercase is more than lowercase, then if whatever is small lowercase letter, we will convert it to uppercase letters, and else we will convert it to lowercase letter. This is pretty simple as well. I hope everyone understands. Any problem? Any doubt? Is it clear, the question and the implementation? Okay, so the third question will be taken by Abhishek.
Hello. Hello, am I audible? Am I audible? Um, Someone in the chat box. Okay, so is the screen visible? And you want to confirm? Um, okay. Yes. So I guess you guys have solved the third question. So I will kind of quickly discuss it. So the problem is relatively like the statement is relatively simple. It's visible, right? Okay, so the statement is relatively simple. For a non-negative integer k, we define a level k carpet as follows. So they first declared, base case kind of. So a level 0 carpet is a 1 cross 1 grid consisting of a single black cell. And for k greater than 0, a level k carpet is a 3 to the power k into 3 to the power k grid. When this grid is divided into 9 3 to the power k minus 1 times 3 to the power k minus 1 blocks. The central block is entirely of white cells, and the other 8 blocks are of level k minus 1 carpets. So you're given a non-negative integer n, and you have to print a level n carpet according to the specified format. So the question is, so what the question means to say is that they have given a value n, and you have to print a carpet of uh, print the level n carpet, and so you have to print the level n carpet, and this basically defines what the level n carpet is. So um, for example, what they're saying is that he uh, um, for level k carpet, it will be a 3 to the power k into 3 to the power k grid, right? So so it will be a 3 to the power k into 3 to the power k grid, and there will be, so it will be made of 9 3 to the power k minus 1 into 3 to the power k minus 1 blocks. Okay, so for example, if we have say k equals to n equals to 2, then if you have n equals to 2, uh, yeah, so if we have n equals to 2, this means we will have a total of 3 to the power 2 and 3 to the power 2 rows and columns. Okay, and this will be made of course, 9 3 to the power 2 minus 1 into 3 to the power 2 minus 1 blocks, right? So this will be something like this, and there will be 3, you know, this, yeah. So there will be 3 rows and 3 columns, and this we will have this like 3 rows and 3 columns, and these blocks will be repeated 9 times, and that forms the level n grid from level n minus 1 place. We will be using this concept later on while we will write the code. Anyways, so what they have said is that so now the main thing is the central block consists of entirely white cells, whereas the other 8 blocks are made of level k-1 carpets. So essentially this portion of any level carpet will be white, and these blocks will be black. These blocks will be black. So what they are saying is, yeah. So these ones will be black. So now they have given, okay, they have said is, yeah, here. So uh, they are using hashtag for black and dot for white. Okay. So if so basically, let's say if you take n equals to 1, if we take n equals to 1, acha, okay, first of all, let's say n equals to n is 0, then what we will have, we will just get hashtag, right? Because that's what the question says, right? uh, yeah, so level 0 is a single black cell, right? We'll just have a hashtag. Now if you have n equals to 1, then we will have here 3, where is 3 to the power 1, then we will have 3 to the power 1, and then we'll have 3 to the power 1 rows, and then we will have 3 to the power 1 columns, right? So again, this is already given, so I'm kind of going over it quickly as possible, and you guys also have solved it. By the way, how many haven't solved this question? Like, oh, only 2 of you have replied that, okay, like you have solved it. So 2 of you have replied that you have solved it. Any other person who hasn't solved it? I will probably go a little slower. Anyways, so so yeah, so if n is equals to 1, then we will have 3 rows and 3 columns, and we will use the, again, we will have 9 3 to the power 1 minus 1 into 3 to the power 1 minus 1 blocks. And what is that? That is like 9 1 into 1 blocks, right? So we have 9 1 into 1 blocks. So these are all the 9 1 into 1 blocks, and what the question says is that the middle block will have a white cell, and the white cell is denoted by a dot, and all of the other cells, all the other cells, is this will have the previous carpet only. So the previous carpet in this case is just for 0, so you will have hashtag this way. We'll have all the cases. So, and that's exactly what the pattern is. That's exactly what the pattern is here, right? And in the similar way, what they have done is that, again, we have the middle part, this part, this, these are all white cells, and then we have, and then this portion is again the previous carpet, this one, and then we have again this portion, again the other carpet, this carpet of the previous carpet, because it's n equals 2. We will use the n equals to 1 carpet for making the n equals 2 carpet. Anyway, so this is what the question fully means, like, and kind of also a part of the solution. So I guess you guys used recursion to solve this question, right? And by the way, is everything clear up till now? Anyways, you guys have solved it, so I think it's probably more or less clear. So yes, okay, that's good. So so again, so this is, you can kind of see that this is a very like recursive structure, right? So we will just use recursion to solve it. So basically, what we will do is that, let's say at at the nth case, we will use the n minus 1th carpet. Okay, we'll use the n minus 1th carpet. So in order to generate the nth carpet, what we will do is that we will, first of all, yeah, okay. So in order to generate the nth carpet, we will use the n minus 1th carpet, right? So let's say we want to generate the second carpet, so we will use the first carpet, okay, like n minus 1, which is the 1th carpet, right? So we will take, so here's a relatively simple pattern here. So here, so this portion, and this portion is, hello, hello, am I audible? There was a disconnect. Am I audible? Is the screen visible? Okay. Yeah. So yes. So if we have n equals to, if you want to make the n equals to 2 carpet, n equals to 2 carpet, we will use the n equals to 1 carpet. So let's say we have the n equals to 1 carpet. So this will, what the n equals to 1 carpet look like, right? So 1 second. Yeah, so this is what the n equals to 1 carpet will look like, right? So um, in order to make the n equals to 2 carpet, what we saw is that we can just repeat this one like 2 more times. That is in total 3 times, right? So we can just do this, 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 and then again this, 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 and this, and so on. However, however, if let's say this again, this will repeat. We will again do this here, same thing. We will repeat this pattern 3 times. However, this middle portion we will have to do some maneuvering so that we ignore the, like when we reach this middle portion, we will only put dots. Only put dots. Okay. So that's the entire goal of the. That's how we will write. Okay. So um, let's get to the code. Okay. So yeah. So what I'm doing is, so you can ignore this and this, right? Anyways, so if I'm calling the solve function, the solve function. Okay. So here I'm first taking the n as input, and then I am what I'm doing is I have made a function called carpet of n, which is this one, and I am storing the answer here, and I print the answer later on after. Like I'm coming back to the carpet function in a moment. Come back to the carpet function in a moment. So this is the carpet function. This returns me the value of the nth level carpet and stores it in n. And I am using a vector of string here. And this is basically to print the output and the cout ender. Anyways, so how does the carpet function work? So my carpet function returns a vector of string. Okay. So um, the carpet. At first I'm handling the base case. So at n equals to 0, it returns simply just uh, the n equals to 0th case, the 0th carpet, which is just one hashtag, right? Now let's say if we have a general case n, so I'm storing the previous carpet value in the previous variable, and I'm recursively calling the carpet function on n minus 1. I'm storing whatever comes from here into previous. Okay, and here I am calculating the current size of the carpet, and I'm also calculating the previous size of the carpet. We'll be using this later on, previous size and the previous size. Okay, so I'm storing the previous size of the carpet in previous value. Now this vector of string is this vector of string called curt will store my current carpets will store my current carpet, and I'm initializing this with size. That means I'm initializing this with 3 to the with size. And what is size? Size is 3 to the power of n. I'm initializing this with 3 to the power of n strings. Okay, n empty strings, and that is what the current carpet is. We haven't done anything yet. So these are actually all of my initializations. Okay, now This is I'm just creating the middle portion, like I'm kind of pre-computing the middle portion, not pre-computing, like I'm storing the middle portion here. What I'm doing is uh, I'm making a, you know, if n is equals to 2, then I'm making a middle portion of size 3 to the power 2 minus 1, which is 3, right? I'm making that middle portion. By middle, what I mean is the, the white portion that there was, like the dot 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 portion, right? So that is what I'm creating now, so that I can append it later on easily. So anyways, so now we get to the actual part which actually makes the carpet, right? So as I said, by using the I will loop through all of the uh, rows in the, I will loop through all of the rows, and then I will use the previous carpet, I will use the previous carpet as a reference, and then make the current carpet, right? So this portion takes care of the middle part. This portion takes care of the middle part. This portion takes care of the middle part. I am coming to it in a moment. So this is just an if statement. If it, it comes here, then it will deal with the middle part. So first, so let me just deal with the else part first, and then I am coming to the if part. So this is if we are, so this is, if this is skipped, then we will obviously go to the parts which is not the middle. So what I am doing is, so as I said, repeat I will repeat it 3 times, right? So I'm running a loop 3 times. So this is from j equals 0 till less than 3, and then what I'm doing is uh, at the um, ith position of the current carpet, I'm appending. Okay, by the way, this dot append function is essentially allows you to concatenate two strings. So if, so you already know that char of I is a string, so dot append will allow you to append another string directly, whereas pushback allows you to append only a character. Anyways, so uh, in the ith position, in the ith string, what we will do is, yeah, so in the ith position, what we will do is the we will append the string, append the string from the previous carpet. So here we are using the previous carpet as a reference. Now remember that now remember that uh, our carpet is actually much bigger, right? So if n is equals to 2, so if n is equals to 2, then our carpet will be 9x9, right? 3 to the power 2, right? 3 to the power 2 into 3 to the power 2, right? However, our previous carpet is 3x3, right? So if our carpet is 3x, so now the thing is, um, we we want, so for example, let's say, um, okay, let me take an example here. So I think I will just um, let's do this. And let's say this will continue, and then we will again have the this again, this, by the way, for n equals to 2. So for n, so we will have something like this in for n equals to 2, right? So Now this is so if we, so what will n equals to 1 look like? N equals to 1 will look like this. Right, so n equals to 1 will look like this. So this is index 0, 1, 2, 3, dot dot dot, and 4, right? So if say we are at index 4, if say we are at index 4, how can I use the previous like how can I use the previous carpets like at index 4? What do we want? At index 4 we want the top row, right? At index 4 we want the top row of the previous carpet, right? At index 5 we want the second row of the index of the previous carpet. So how will we you know access it? So let's say we if I am at uh, if I am at position I equals to 4, if I am at position I am at row I equals to 4, how can I access the previous carpets I equals to actually sorry, this will not be I equals to 4, sorry, this will be 0, 1, 2, 3, 4, 5, and this will be 6. Sorry, I'm really sorry. This will be actually 6, this will be 6, and this will be 7, and so on, right? So this will be 6. So how can I access the previous carpets I equals to 0 as well? How can I do that? Do you guys have an idea? It's relatively simple. I guess I'm framing the question a bit weirdly. Anyways, so if we are at the 6th row, what I'm trying to say is this will be kind of circular. So if we are at the 6th row, if we are at the 6th row, then we want the 0th one. If we are at the 7th row, we want the first the 1th column. And if we are at the 8th row, then we want the second column. So this is essentially what? This is essentially if you are at the ith row, we want I mod we want I mod 3, right? Yes, I mod 3, which is the previous carpet size. Yes. So if you are at the ith row, we want uh, the previous. We want we want to access I mod previous carpet's size. So that's exactly what I'm doing. So at the ith position, I am 3 times appending previous carpets I minus previous size at row. So that is what this function is doing, right? And finally, so this generates all of the parts. That generates all the parts. This generates all the parts which are not in the center. And finally, we have this part which deals with the center. So I just add a relatively simple exclusion, not exclusion, a relatively simple if-else condition. So remember that. Um, here what we are doing in this portion, what we are doing, we are simply copying the previous carpet 3 times. Here also we are doing the same thing. However, here what we are doing is that rather than copying it 3 times, we only copy it 2 times. But in the middle, only in the middle, we put dots. So that's all we do. So we just, so also by, so this condition tells me that, okay, I am in the middle. So again, this is very simple why this condition comes up. So let me erase this portion. This is also a simple why this condition comes up. So you can see, so we know that the dots will be here, right? And here will be the dots, here will be the dots, here will be the dots, right? So let's say, so so at the, so here we are seeing that at the third row we start getting the dots, and we end at the fifth row, at the fifth row. So so what is 3? 3 is previous carpet size, right? Previous carpet size. So from I equals to previous carpet size till I equals to previous carpet size plus how much? This will be previous carpet size plus 1, right? Which is essentially we are considering the range I greater than or equals to previous carpet size and less than 2 times previous carpet size minus 1. Actually, this will be minus 1. This will be minus 1. Yes, 2 times previous carpet size. So that's exactly what I'm doing. When I am in this row, in these rows, so I equals to previous carpet size and I is less than this, then when I done a for loop from 0 till 3, when I'm in the middle, I only append the dots. Again, remember the middle variable that I had initialized was just dots, and otherwise I append the usual way. And this pretty much makes the entire carpet, and finally I return the carpet, and um, that again gets stored in answer, and then we print. So yeah, this is how this is solved. I guess it's quite clear because you guys already solved it. I guess there's another person who probably hasn't. So is it more or less clear, like how I approach this question? Yeah. Yeah. So um, this was the third question, right? So um, as for question D, I'm going to give you the idea how to solve this. First of all, you need to know how to do binary exponentiation for this. Okay. So do you guys know binary exponentiation? Okay. Acha, you need to know basically kind of two things: binary exponentiation and modulo inverse, modulo multiplicative inverse. Okay, like when you when you will when you get to know binary exponentiation, modulo inverse is relatively simple. So the D question, I'm going to read it out. So for positive integer n, for a positive integer n, let Vn be the integer formed by concatenating n exactly n times. More precisely, consider n as a string, concatenate n copies of it, and treat the result as an integer Vn. For example, V3 is equals to 333 and V10 is equals to 10, 10, 10, 10, 10. Right. So essentially, whatever is whatever n you are taking, you will repeat it that many times. Here, here here you are seeing n 10 times because n is equals to 10, right? So you have to, so the question is you have to find the remainder when Vn is divided by this number. Okay, so I'm going to give you a hint here. I'm not going to fully solve the question, I'm going to give you a hint. So what you have to do is you express this you express this number you express this number uh, as what do I say? Like let's say we have 333, right? So you express 333 in terms of its in these terms: 3 into 10 to the power of 2 plus 3 into 10 to the power of 10 10 to the power of 1 plus 3 into 10 to the power of 0. If you simplify this, you will get a formula, and I'm sure you guys will be able to simplify it. It's basic math from class 11 and 12. If you simplify this, you will get a formula. Now, in order to calculate this formula, you will have to first, oh yeah, yes. So in order to calculate this formula, you need to you will have a few exponential here, a few exponential terms. So in order to calculate those exponential terms, you need to know binary exponentiation, and you can, and it's relatively simple. It's not that tough. So you will use binary exponentiation to exponentiate those terms, and then you will have to calculate, and there it will be a fraction. So you will have to calculate the exponential, and then you have to use a bit of modular arithmetic. So I will suggest you to first at least see what binary exponentiation is, how to do some modular arithmetic. Like, it's relatively simple. It's not that difficult. So you have to use binary exponentiation and some modular arithmetic, and then you have to. So after calculating those exponential terms, you have to then calculate the modular inverse of the denominator, and then, like, I'm not going into the details, and then you have to do a little bit more, and then you will get the answer. So I'm just giving the hints here. I'm like, I kind of gave the big hint away here. So you should, the main thing is you need to know these two things: modular arithmetic and binary expo. So I guess, acha, someone shared a solution. So, like, did it run? This gave right answers for smaller values. Well, the thing is, and you're taking C and N, right? And then, uh, acha, okay. So, like, the thing is, it will actually probably give correct answers for smaller values, because the thing is, here n is 10 to the power 18, right? N is equals to 10 to the power 18. So if here you can see that you are doing s2i, so string to integer, right? However, if you have n equals n, but here n is 10 to the power 18, right? So what does that mean? That means That means n has 18 digits at least. N has 18 digits, right? And n has 18 digits. Now you will repeat. So n has 18 digits, and now you will repeat those 18 digits 18 times, right? So the total number of digits will be 18 into 18. So what is that equals to? That is equals to, wait, let me check. That is equals to 324. So you have a number which is 324 digits long. So the size of that number is 10 to the so essentially that's the size of the number is of order 10 to the power 324. So that's why your program will not run. You're doing s to I, right? String to integer, and then you are doing the modulo, right? So what is the maximum range of longing? 10 to 16, 10 to the power 64. So sorry, 2 to the power 64, right? But 10 to 10 to the power of 324 is very large. So of course it cannot store that. So you have to, again, as I said, you have to use like you have to kind of work through the numbers, and you have to use a little bit of algorithms, like you have to use binary exponentiation, modular inverse, to actually calculate that in a relatively faster manner, in a manner which the computer can handle, right? So yeah, so those are the hints that like you, it's not much of a hint. It's like, you, okay, if you don't know these topics, then you can um, you know if you know these topics, then you will more or less be able to solve it. It's like, so this problem was like, okay, if you don't know the topics, then go and learn these topics. It's kind of that, right? So yeah, so that's how D will be solved. So are there any like doubts, questions? The size number was that's why if DLE, that's true. Yeah, I guess that might that should that one that's one of the problems. So yeah, are there like any other doubts, questions you might want to ask? So I guess, yeah. So that's pretty much the contest post contest discussion. So I guess we will wrap up now.